Hello and welcome to a Math Minute, a quick how-to over a topic that's been troubling you. The topic for this video is expanding a binomial, and this is part 2. This one is much more pattern-based, and there's some patterns that we need to talk about as we do this video. There's also some, prior knowledge that we also need to have as well, and that is Pascal's Triangle. You have to be a little familiar with Pascal's Triangle, at least what it is and how you can create it. So Pascal's Triangle, starting with the 1, 1, 1 on top, these three triangles of ones here. And then all you do is you simply add two numbers together to get the number below it. So 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, etc. Always start a row with a 1, end a row with 1, and the numbers in the middle, that's how we create them, by adding the numbers above them. Now, it just so happens that the numbers in Pascal's triangle, the rows of numbers represent the coefficients of the terms of the binomial expansion. The power, or we'll talk about this as we expand this, but the rows, they start like this. The top row is 0 power, the next row is first power, next row is second, etc. And of course, this triangle just keeps going. You can keep writing these out. Now, this problem that we have is a fourth powered problem. It's the exact same example that I did on another Math Minute over expanding binomials. So you can take them side by side and you can watch the the difference between the two techniques. So I want to use this row right here. This 1, 4, 6, 4, 1 row. Now, here's how the pattern works. I'm going to write it out and I'll kind of try and explain it as I go. The first term of the expansion is going to have 1. We're going to have 2x to the fourth, and we're going to have 3 to the 0. So notice I've got the first number there of the row in the triangle. I've got a 2x because there's a 2x in the binomial. I've got a 3 because there's a 3 there. Let's write the next term and we'll start to see how some of these patterns emerge. The next term is going to start with a 4 because there's a 4 there. I want 2x to the third, 3 to the first. Next term is going to start 6 because that's the next number there. I want 2x squared, 3 squared. Next number is going to start with a 4. I want 2x to the first. I want 3 to the third. And then the last term, because it's only the last number of my row of the triangle, I'm going to have 1. I want 2x to the 0. I want 3 to the fourth. All right, so it looks like a mess, but it's going to clean up real nice and neat. Let's kind of talk about the patterns real quick. Besides the 1, 4, 6, 4, 1, which are the numbers in the row of this triangle, what you see happening is that every term has a 2x and a 3. All right? They all have the same two terms that we see right here in the binomial. Now, also what happens is the powers. Notice how I adjusted the powers. The 2x started with a fourth power, went down to 3, 2, 1, and 0. 3 started at 0 and went to 1, 2, 3, 4. So the powers of the terms, they have this -1 plus 1 pattern where I'm taking one away and I'm adding it to the other exponent. Also, the powers of the terms here, 4, 0, 3, 1, 2, 2, etc., those powers add to 4. So basically, just always start with the power you see and 0, and then just adjust them by minus and plusing 1. Okay, now let's go ahead and simplify this so we can finish this up real quick. 3 to the 0 is just 1, so that's not going to matter. 2x to the 0 down here is 1, that's not going to matter. Obviously, multiplying by 1 doesn't change anything, so just kind of clean those things out. This first term is just 2x to the fourth, so 2 to the fourth is 16. X to the fourth is x to the fourth. Now this next term, I'm going to do a little bit of scratch work or mental math here. 2x cubed, so the 2 to the third power is 8. And 3 to the first power is 3. And I've got the 4 there, so I need to be able to multiply 4 times 8 times 3. And 4 times 8 times 3 is 96. The x was cubed. Next term, I have 6. 2 needs to be squared, which makes it 4. 3 needs to be squared, which makes it 9. So 6 times 4 times 9 is 216. The x is squared. Next term, I got the 4. 2 gets to the first power, which is 2. 3 is to the third power, which is 27. 4 times 2 times 27 is 216. X is to the first power, so just x. And then finally, the last term is just 3 to the fourth power, which is 81. That's it. There's our binomial expansion of 2x plus 3 to the fourth power. With a little bit of practice, this is something that can be done mentally, I think. If you're pretty good with your math fluency and multiplication facts, and if you got that pattern, you can definitely do this mental math, or at the very least, you can write out one step of work and then get right to the answer. So that's my expanding binomials part 2 video. That's going to wrap up this Math Minute. If you found this video helpful, please give it a thumbs up. If you have any questions about the video or suggestions for a future Math Minute, please feel free to leave them in the comment section below. I thank you for watching.